So earlier we studied about the tensile test on torch steel. So the next experiment we are going to study is the tensile test on mild steel. All the experimental process remains the same, only the type of bar will be changed. So once again, this is the control panel, this is the Glody frame, and here we are going to use a MS bar. So the title of experiment is to determine the tensile test on given mild steel specimen and to plot the stress strain curve and other curves for the given bar. So again the basic theory is MS bar is widely used in construction work, but nowadays torch steel is mostly used, but earlier mild steel was usually used in construction. So how much tensile load it can carry, it is a ductile material, and how it behaves when the load is applied, like elastic limit, upper end point, lower end point, which we studied theoretically in unit number 1, which is simple stress and strain. We have to see practically whether the curve is being seen when the load is applied on this unit cell testing machine. So again, the requirement is a unit cell testing machine, tape to measure this length of the rod, and a vernier caliper to measure the diameter. So first we'll measure the length of this MS bar. MS bar is a plain bar, as you can see, as compared to the torch steel bar. You can see here the major difference. Torch steel bar has grips around it, threading around it, and mild steel bar is plain, a smooth surface. So you should understand this simple difference. Now we measure the length of this bar. So the length of this bar is around 450 mm, means 45 centimeters. We will measure the diameter using vernier caliper. So this bar has perfect diameter of around 12 mm. Using vernier caliper we have defined. Now we will fix this bar in between top and middle portion of this UTM. First, fix in the top portion. We have marked the gauge length, which is 5 times of diameter. Now gauge length is gripping length here, which it is around 10 centimeter from both the sides, so that the bar requires that much grip for the load application. So fix the bar in the upper portion firmly, and now while fixing this, you have to keep this wall open, which is pressure control wall. Now move this upward. You have to move this upward until the point where we can fix that bar up to grip portion. You have to fix this middle portion firmly so that the load gets applied. See whether the bar is fixed firmly. Now our bar has been fixed in this UTM. Now we will close this wall. We will close this wall. Now the wall is closed. We will start the experiment. You have to input the diameter, which is 12 mm, gauge length is 450 mm, and start with the experimental setup. This is the screen which will be seeing of load versus displacement. Now we'll start the load on this control panel, and at the same time start on this graph and start opening this load regulation valve, means start applying the load of this bar. We will start. You can see the pitch load is being applied. you can see the load is being applied between the top and the middle portion. You can see the load is being applied around 75 kN. Load is being applied till now and 7 mm displacement is seen. At some point the peak load will reach and the load value in the second place will start reducing. Means the peak load will be applied and then it will start reducing and will finally break. As we see that we have maximum load and breaking load on the stress strain curve. Same thing follows here practically. Around 83 kN load is being applied. We will see whether there is any portion showing the breaking. After increasing above beyond certain point, it is remaining stable at that point and moving gradually. See, 85.78 kN is the maximum load reached and the load is reversing down. We'll see, you can see, and the bar is broken. Now you can see the bar has been broken successfully and it has broken in the form of cup and cone shape. You can see here in detail the cup and cone shape. Now we will measure the final length of this bar using tape. And the final length is around 465 mm. 465 means 46 centimeters. So we write here 465 mm, and we have to measure the final diameter using vernier caliper. Use vernier caliper. It is around 8.9 mm. So we put it here final diameter as 8.9 mm. Here the output, which is load displacement curve. The maximum force is 85.78 kN, displacement is 18 mm, and tensile strength is around 0.758 kN per mm square. And also you can see load versus displacement curve, then stress versus displacement curve, and stress versus strain curve. So in this way, this is the procedure to find the tensile test on mild steel bar.